Hello everyone. We'll start in 5 minutes. We'll wait for others to join. Shall we start the class? Can someone tell me? Okay, let me start the class then. So today we will be discussing about earth pressures. In the initial classes we have already discussed what is earth pressure and what is retaining wall and all. But again I will repeat briefly and then we will enter into the problem. So I'll be sharing Can someone tell me, can you see the screen? Now can you see the screen? Slide. You can't see anything? Can you see? What is there? Can you read out one, just any sentence? Okay. So I think so. I hope everybody can see it. So I'll be starting the class. If anybody is unable to see, just let me know. Okay. So here let's go through the question first. As per Rankin's theory of earth pressure, the inclination of failure planes is 45 plus phi by 2. So 45 plus phi by 2, where phi is friction angle. Remember that. Okay. The angle of inclination of the failure envelope in the Morse circle, the Mohr-Coulomb failure envelope, with respect to the direction of the minor principal stress. Anyway, let's go through the question again. As per Rankin's theory of earth pressure, the inclination of failure plane, suppose there is a failure plane, so take any soil sample. Okay, suppose I am taking a soil sample like this. So when you are applying pressure, okay, what happens? It fails along one plane. That means this total part of the soil sample, it goes down or up. If it is going down, that means this total part will go up. That means the failure is happening along this plane. So this failure plane angle, the angle of inclination of the failure plane, okay, it may be with vertical. Okay, yes. So at least can you see the slide on which I am writing? Yeah, first slide only, but on that slide I am writing. Can't you see? Okay, on the same slide I am writing actually. Anyway, okay, let me share again, reshare again. just a minute. Hello everyone, what do I do? First I'll leave the meeting from my side, then I'll join again. Okay, you can be on the, just let's check. Okay, I'll leave the meeting. If at all you are also out of this meeting, once I close the meeting, please join again. Okay, in 1 minute. Please be there, you don't close, I'll close and I'll reshare, I'll again switch on. Okay, is it fine? Okay. So I hope you can hear me now. Can you? Yeah, let's check the sharing part. Okay, let's, let's try. Okay, can you see now? Can you see the diagram which I have drawn there? Yeah, this part. Can you see this part? Yeah. Anyway, so I'll be repeating the question. As per Rankin's theory of earth pressure, the inclination of failure plane is phi by 2, 45 plus phi by 2, 45 plus phi by 2, whereas this is phi is friction angle. Okay, so this inclination of failure plane, what I'm saying is that when you take the sample, when you are applying some loads like this, okay, what happens? It fails into two parts. Along one plane it shears. That plane is having some inclination to horizontal line and vertical line. Okay, so he is saying that angle is 45 plus phi by 2 with respect to the direction of the minor principal stress. You remember this. This is the inclination of the failure plane is 45 plus phi by 2 with respect to the direction of the minor principal stress. We don't know what is the direction of minor principal stress. Let us say minor principal stress is acting in this direction, then failure plane will be in this direction, and this is 45 plus phi by 2. That is what he is saying. The above statement is correct for which one of the following options? So let's see. Only the active state and not the passive state. See, it is all about the earth pressure. In earth pressure we have already discussed one day that what is active state, what is passive state, what is active earth pressure, passive earth pressure. Anyway, I'll go through them again briefly now. So now let's read the options. Only the active state, not the passive state. Only the passive state and not the active state. Both of them, neither of them. So those are the options. So in which state this inclination of the failure plane is equal to 45 plus phi by 2 with respect to the direction of the minor principal stress. Okay, let's see that how it is. So now let me draw retaining wall. Okay, so let us say this is retaining wall, this is earth material. Okay, and this is retaining wall, this is earth material. So what happens with this earth material? This earth material applies some pressure on this retaining wall. This is retaining wall, let us say, right? And another case I have told you, I will talk about that. This is, so this is inside the ground. So this is just a support foundation. Anyway, so whenever the soil is applying the pressure load on the retaining wall, what happens? This retaining wall it will try to move in this direction. Okay, that means whenever it is moving in this direction, it is going away from the soil, right? If this is the soil, it is going away from the soil. So this state is called active state. Okay, this state is called active state. So another state is what? Another state is passive state. So when does it happen generally? So now let us take different levels of earth material on both side of the retaining wall. Okay, both, see this is left side, there is some earth material, right side also there is some earth material. Now this is retaining wall. So because of this earth material, it will try to move in this direction, right? Because the more pressure is on this side. So whenever this is moving in this direction, compared to this soil, with respect to this soil, what is happening? This retaining wall is moving towards, okay, towards this soil, So that, let us draw this. Okay, suppose retaining wall is moving in this direction. Okay, here it is going away from this soil as well as it is going towards this soil. This side is called passive state and this side is active state. So remember that whenever wall is moving away from soil, that is active state. Then wall is moving towards, okay, towards the soil, is passive state. These are the things. Now going into the, so when we were discussing about the active state, let us take this. Okay, now I am discussing about the active state. Okay, now in this active state, this is moving away from the soil, so I am talking about only active now. Okay, now let us take a soil sample. Okay, now whenever it is moving in this direction, this soil fails along this retaining wall. This total soil wedge, this part will move downward direction. Okay, downward direction, because it is moving in this direction. Okay, then finally soil will fail like this. So in that way, this soil wedge is moving downward direction. Because of that, see, any sample you take, any sample, I'll take this at this place, any soil element you take, there are stresses on this soil sample. One is vertically downward and upward. If you take, see, soil is in compression. You remember, if you take any sample, that is not getting extended. That means what? It is in compression now. Okay, now when it is in compression, let us say, see, this is sigma v, because it is vertically in vertical direction. This is sigma h. Now the concept behind, see, some people may ask me that when the retaining wall is moving in this direction, this element should be expanded. That means there should be stresses in this direction, whereas this is fine with you. Maybe you may accept this because vertically downward, because of that soil may be in compression. But whereas when the retaining wall is moving in this direction, you may say that this is extending. It's not. Why? I'll tell you. See, when the another part I'll discuss active condition, at rest condition. Before continuing this, I'll tell you about at rest condition. See, when the retaining wall is not moving, it is still there, it is not moving this direction or this direction, okay, then that means what? See, there is a soil. If at all you remove this retaining wall, what happens? This soil will collapse completely, it collapse and it will, suppose retaining wall is not there, then what happens? Soil will, like, it comes like this, right? It goes like this. This is what the diagram I have written. It goes like this if retaining wall is not there. You have constructed retaining wall so that this soil will stand like this. That means what? You are already putting this soil in the compression. Otherwise what will happen? If you remove this soil, remove this retaining wall, it is falling. That means it is getting expanded. That means it is free to move. Whereas when the retaining wall is not, when the retaining wall is there, it is not free to move. That means it is in compression initially, right? Before wall moves this direction, it is in compression. By default the soil element is in compression, okay. Suppose let us say this is 100, just let us say this is 100 kPa, this is 100 kPa, just these are random figures, okay. I am not telling these are the actual figures, some 100 kPa is there, right? So when the soil is in compression, soil will not fail. At least one of the planes should be subjected to such shear stress so that it will fail. Now what is happening when we are moving in this direction? Now this is at rest condition when 100 is there. When we are moving in this direction, this 100 will get decreased, right? Maybe 100 will become 50, but still it is in compression, right? At one point, though, now it may be 50, okay, now it is 100, okay. What happens? Let me check. Okay, can you see the slide? Can someone reply? Can someone reply? Yeah. See, now what happens? Now 100 is there. See, why only horizontal is decreasing? Because vertical, there is no pressure which is applied vertically. There is no extra load, extra surcharge. Because of that, 100 will be 100. The only change happens only in the horizontal pressure. I told you in the initial classes that the change in the earth pressure will happen only in horizontal direction. That means only sigma h will change, whereas sigma will not change. Sigma will always be constant. Now these are random figures. See, it may be 120. I am not saying that all should be equal initially. It may be 100, it may be 120. But at the end, what is happening when it is moving away from the soil? This 120 has become 50, but it is still in the compression, right? At that point, this soil may fail. Okay, that is the reason why I have taken compression, all compression. Now this is sigma h, this is sigma v, right? See, and one more thing I have discussed in the previous class, that the collaboration between the Mohr circle and the earth pressures. I'll draw them now, okay. So this is what. Now suppose this wall is moving in this direction. What is that? That means passive. It is in the passive condition now. At that time also, this sigma h will only change, but instead of 120, now it will become it will increase instead of decreasing. Let us say 150. It has become 150. At that point again soil may fail, okay, due to changes in the stress. But the change happens only sigma h. That is one thing. And second thing is, whenever this wall is moving, sigma h will increase. Whenever wall is moving this direction, sigma h will decrease. That's it. But finally element is in the compression only, all sides. That is what you have to remember. Now going to the Mohr circle, okay, going to the Mohr circle, let us say at rest condition, let us say at rest condition, see, this is sigma and this is tau. So we are going for the Mohr circle as well as Mohr Coulomb envelope. So now at rest condition, when the wall is not at all moving, at that time soil element, let us say it is in let us say sigma v sigma h, okay, sigma v sigma h. Take any condition, sigma v may be more than sigma h, sigma v may be less than sigma h. See, both, anything can happen at rest condition. Suppose wall is not moving and there is some soil, okay, wall is not moving, you take any element, sigma v can be more than sigma h can be more than sigma v, anything. Let us consider sigma h is more than sigma v, okay. And you know, for one soil structure there is a fixed failure envelope, okay. Let us say there is a fixed failure envelope. This is the failure envelope, okay. Now taking sigma v and sigma h, which are on two perpendicular planes, so you can draw a Mohr circle. See, this Mohr circle is nothing but points of all the planes. Now it is not touching, that means what? Still the soil sample is safe, in the safe condition, it is not touching this. Now when you are moving to active condition, what will happen in the active condition? Sigma h will decrease, right? We have discussed in the previous slide. When you are going in this direction, what will happen? Sigma h will decrease. So sigma h will decrease, right? So I should have drawn from this side. Okay, let me draw. We have taken which condition? Sigma h is more, right? Sigma h is more initially. So initial Mohr circle is like this at rest condition. This is at rest condition. Now what is happening? When wall is moving away, that means in the active condition, it wants to reach active condition, sigma h will decrease. So sigma h is decreasing. What happens? Sigma h has come, let us say here, but sigma will be, v will be there only. So now sigma h decreased. At one point it will come here, right? Like that, sigma h will be at one point, it will be equal. Then sigma h has come here, okay. Now sigma h has come here. It will decrease until which point? Until at some point, so that the total final Mohr circle will be, sigma v will not change. Remember, when sigma h finally, whenever it reaches this point, the Mohr circle is touching failure envelope. At this point of sigma h, it is still in the positive direction, okay. All compressive forces are positive. That's why I have taken sigma v right side of the y-axis, sigma h also right side of the y-axis initially. Finally what happens? The Mohr circle is reaching within this right side of the y-axis. That means it is still positive, still compressive. It will not become negative or it will not become tension, okay. Now see, at the failure condition, what is happening? Sigma h is falling left side of the sigma v, okay. This is how Mohr circle for the active condition, okay. This is how Mohr circle will for the active condition, right? Now suppose I will start with this circle. That means sigma h is already less than sigma v. This is the initial circle. Now you are again starting active condition. Then what happens? Again it will decrease only, right? From this circle to this circle it will reach. At the end, for active condition, sigma h will always be less than sigma v for active condition, okay. For passive condition, again sigma h will only change, but in this passive condition, sigma h will increase. Okay, so finally sigma h will go in this direction. Okay, like this, sigma h will go in this direction, then finally it will reach. That means at the end sigma h is right side of the sigma v. That means sigma h is greater than sigma v. Suppose in the initial state sigma h is less than sigma v. Now you are applying passive condition. Sigma h will increase. It will go here. Okay, it will go here. Then it will go here. Like that again it will reach this point only. So finally sigma h will be greater than sigma v in passive condition. So these two you should remember. So let us go to new slide. So for active condition, sigma v is greater than sigma h. For passive condition, sigma h is greater than sigma v. These two are the things. Now let us take soil element. In the soil element, sigma v is always vertical, of course, sigma h is always horizontal. Okay. Now whenever whenever you take the retaining wall and the soil element behind it, the soil element and the vertical plane, this one, and a horizontal plane, these two are always principal planes. Remember, principal planes. Why? Because there are no shear stresses. These two are, this is principal plane and this is principal plane. Why? Because no shear stresses. These are the, you know what is principal plane now and what will be there in the active and passive condition, and what you have to find out. Here the question is asked. Okay, we'll draw first. We'll draw according to the Rankine's theory. It is for cohesion less soil. That means phi will be there but cohesion will not be there. So when the cohesion will not be there, the failure envelope will pass through origin. Okay, so okay, let us say this is the Mohr circle at failure. It is touching this Mohr failure envelope. Okay, this is friction angle, right? And C is 0. That's why it is going through the origin. And what is this? This is tau. This is sigma. And this is Mohr circle. Now, what are these? Here some sigma will be there, but tau will not be there, right? Here also some sigma will be there, tau will not be there. Now, let us say we'll go active condition first. Okay, we'll do this active condition first here. So for the active condition, what is less? Sigma h is less than sigma v. Now tell me, this should be sigma h, because sigma h is less than sigma v. This should be sigma v, right? Now, so I am taking an element. So sigma is like this, sigma h is like this always, but in this condition, active condition, sigma v is greater than sigma h. That's why sigma h is here, sigma v is here, and I want to find out the pole. You might have heard what is pole. This is to find out the plane of failure plane angle. To find out the failure plane angle, you want to find out the pole. So how to find out the pole, I will tell you now. So what you have to do is, you know the 2 points, right? And you know where does it act. See, sigma h will act on vertical plane, right? That's why you draw one vertical line through sigma h. Okay, I am drawing one vertical line through sigma h. And where is this sigma v acting? Where is sigma v acting? It is acting on horizontal plane. So what do? I'll draw one horizontal line from this sigma v. Now these two lines, whatever lines I am drawing, these two lines are interacting this point, at this point, that is called pole. Okay, you remember, this is called pole. Now from the pole, whichever line you draw, you can find out the angle of inclination with respect to this horizontal plane. Suppose I am just randomly I am drawing this line. Okay, now there is some point here, some sigma will be there, some tau will be there. Where are these 2 points are acting in this element? Suppose I will ask, what do? You just find, you will draw a line between pole and this point. Okay, now you will find out this, let us say this is some angle alpha. Okay, this alpha you will calculate, you will say, you will draw one line alpha, and this is the plane you will say in this sample. That is how pole is used. Now, so this is the failure point because it is touching this circle at this point. So let us say this is F point. How to find out the angle of inclination of the plane on which it is acting? I'll just draw one line here. Okay, and I will find out what is the angle. That angle is nothing but failure of inclination. Okay, I'll go to the question. So what is that? Inclination of the failure plane. That is what we need to find out. Okay, inclination of the failure plane. How to find out? You take the failure point, you take the pole and join them, and whatever is the angle, that is called inclination of the failure plane. Now please find out what is the angle this. If you find out this, then we will write that angle in the active state. Okay, suppose this is the center and this is the active state. We are talking about active state because sigma h is less than sigma v. So in the active state, okay, I'll just draw nicely. Okay, this is sigma h, this is sigma v, and this is failure point. So now this is the angle which we need to find out. Okay, in the active case, what do? I'll just denote it by angle in the active state. Okay, so how much is this? We know this is friction angle, right? Like this, and this is center, let us say this is O. Okay, can you tell me what is this angle? Somebody, if this is friction angle phi, what is this using this trigonometry? Can you tell me? This is, let us say this is O, sorry, this is not O, let us give, this is C, this is O, this is F. Now I will give this as A, this as A, O, A, C, F. Can somebody tell what is A? Angle A. Or what is that? Nothing but FAC. What is FAC? You may not be knowing the proof, but you can tell me. Okay, let's solve that. Okay, let's solve that. What is that? See, this is friction angle, and we know this is tangent and this is radius. Okay, because it is starting from the center, this is radius. So, and this is the line between the point of intersection of circle and tangent and center. So it must be 90 degrees. Okay, if it is 90 degrees, then what is this? This is 90 minus phi. So in this big triangle OC, okay, OCF, in OCF this is 90, this is 90 minus phi, this is phi. Now what shall we do? We will find out in this triangle, triangle AFC. So this is one angle, this is one angle, this is one angle in that triangle. Now we know this 90 minus phi, we don't know this AA, that is what should be found out. And what is this? If you know this, then you can find out this. The only thing which I know, this is also radius, this is also radius. That means this angle and this angle are equal. So you can write this also as AA, right? Because this is radius, this is radius. There are rules, trigonometry rules. The opposite angles of equal sides are equal to each other. So then I can, what do I do? 180, the sum of these three angles, 90 minus pi plus AA plus AA plus. So 90 minus phi plus AA plus AA should be 180. So what is AA now? 180 minus 90, 90 minus phi, 2A is, so it will be 90 plus 5, sorry. This is AA will be, hello, AA will be 45 plus phi by 2. Okay, this angle is 45 plus phi by 2. 45 plus phi by 2. And this is what? Which state? This is active state. Right or not? So now this plane is failure plane. Angle, this this plane is failure plane. Why failure plane it is? Because this is pole and this is the failure point. Whichever the line you are drawing in between that point and the failure point, for pole and the fail, this is pole, but this is pole and the failure point you are drawing, that's why it is failure plane. Now failure plane is doing how much angle? 45 plus phi by 2 angle with horizontal, right? And with vertical how much it is doing? With vertical how much it is doing? Can someone tell me? If it is 45 plus phi by 2 which is failure plane is doing with horizontal, with vertical how much it is doing? It is easy to tell. Can someone reply? Exactly. So anyway, now let us go to the question. Sorry. Let us go to the question. Question is talking about it is 45 plus phi by 2 with respect to the direction of the minor principal stress. Okay, remember. So let us see what is the minor principal plane it is. So this is sigma V, this is sigma H. Okay, what is minor principal stress, what is major principal stress out of these two? Sigma V is major or minor? Sigma V. Okay, sigma H is minor because sigma H is less. So now sigma H direction is what? Which direction it is? Horizontal or vertical? Horizontal direction, right? That means in the active state the failure plane is doing 45 plus phi by 2 angle with horizontal, that means with minor principal stress direction. This is minor principal plane, but this is minor principal stress, this is the direction. So you can say in the active state, failure plane is making 45 plus phi by 2 angle with respect to minor principal plane. Okay, that is what proved. But what about in the passive state? That we don't know, right? We need to find out that. So in the passive state, sigma v, sigma h, okay, sigma h, sigma v. Now again let us draw sigma and tau. So I am drawing Mohr circle. Okay, so as we know, in the passive state what happens, see this is done. So in the active state the given question is correct, but in the given question whether it is correct or not for the passive state we don't know, we are just trying that. So now tell me whether this is sigma v or this is sigma v. Which is sigma v out of these 2 points? Let us say this is point 1, point 2. Which point 1 will be sigma v, because sigma v is lesser than sigma h in case of passive. So now this is the condition of the Mohr circle, right? Now sigma 2, we will find out the pole. Where is the pole? For pole we have to draw the 2 vertical and horizontal lines. So let us draw first. Sigma h, he is here, sigma h is acting on vertical plane, so I will draw a vertical line here. Okay, I will draw a vertical line here. And sigma v is acting on horizontal plane, so I will draw a horizontal line here. So both are intersecting here, that means this is pole in this case. So now what is failure point? This is failure point. And what is this angle? This is phi. Okay, now what do we do to get the failure plane angle? We will just join these 2 points, that's it, pole and the failure point. So whatever is the angle, this, let us say this is alpha, so this alpha is the failure angle. Okay, now how much is this? How much is this angle? What is alpha value? Sorry, what is alpha value? Can someone tell me? Anyway, let me connect this. Okay, let me connect these 2 points. Let me give 1.2 and f. What is this angle? Can someone tell me what is this angle? 90 degrees. Why? In the semicircle, you have to say in the half of the circle, whenever the angle in the semicircle is always 90. Yeah. So if this is 90, can you tell me what is alpha? This is 45. Why? So always it is 45. Can't it be 30-60 or 60-30? That is fine. Why should I take? In the previous slide I took these 2 are same because this is radius, this is also radius, these 2 are equal, that's why these 2 angles are equal. Okay, then I could find out what is AA. But here I am not saying these 2 are equal, I can't even say, because this is not even radius, or this is some chord, this is chord. It is simple. See, this is phi, we already found out what is this. This is 45 phi by 2 in the trigonometry, this angle, right? If this is center, we already found out what is this, 45 plus phi by 2. Now in this big triangle, you see, in the big triangle, this is 90, this is 45 plus phi by 2, this will be exactly, this is 45 minus phi by 2, right? Now in the passive condition, now can you tell me what is this angle? Can someone tell me this angle? So finally what is this? Plus plus phi by 2. Now right, now what is happening in the passive condition? This failure plane is making this much angle 45 plus phi by 2 with vertical plane or with vertical direction, right? Now let us see what is minor principal stress here in this. What is minor? No, what is minor principal stress in this passive? Sigma V. What is the direction of the sigma V? Vertical. So this is also vertical. Okay, this is minor principal stress direction in this passive case. So what is happening? Again, in the passive condition also, failure plane is making 45 plus phi by 2 with respect to minor principal. Okay, ask me. See, stress is low. This is minor principal stress. And yeah, out of these two. Yeah. So now here also in the passive condition, again it is making 45 plus phi by 2 angle with respect to the minor principal stress direction. See, in the both, but the only thing is in the passive condition it is vertical, in the active condition it is horizontal, the direction of the minor principal stress. Otherwise this is always making 45 plus phi by 2 with respect to minor principal stress, right? So what is the question? In the question, the inclination of failure plane is 45 plus phi by 2 with respect to the direction of the minor principal stress. The above statement is correct for one of the following, whether it is correct for active state and or passive state. Sorry, only the active, not the passive. Only the passive, not the active. Both active as well as passive. Neither active nor passive. Can you tell me what is the option now? C. C is the correct answer. So now you understood the concept behind it? Yes, okay. So can I move to the next question? Okay. So for this question we need to discuss few things. See, first we will read the question. See, before 8 I will stop this session. Whether we are completing this question or not, it is okay. I can continue in the next class, but anyway by 8 I will complete. Whatever it is, I will stop there. So the inside diameter of the sampler tube is 50 mm. I will tell you everything. The inside diameter of the cutting edge kept such that inside clearance ratio is 1% to minimize the friction on the sample as the sampler tube enters into the soil. So the inside diameter in mm of the cutting edge is how much? See, here he is saying sampler tube. So you should, once you complete the course, then you will understand what is sampler tube and what is cutting edge, what is inside diameter, all those things. This is, you must have understood now what is the meaning of sampler tube. Sampler tube meaning is, it's like to collect a sample, we will it's like not you can say that it is boring tube. It is suppose you take a soil. See, this is the ground. What do we do? A hollow cylinder, okay, which has sharp edge at this point, okay, like this, there are sharp edges, then that is sent inside like this, okay, then it will be sent inside with some pistons and all, okay, some hydraulic jack systems. Then at the time what will happen? Soil will be there inside, soil will be entering, okay, it will cut soil and it will take a soil which is in terms of solid cylinder. Okay, now after taking the sampler, which is the steel tube, hollow cylinder, this is, so after taking out, inside completely soil will be there, soil is filled, that soil is taken out, the soil looks like this at the end, okay, because it is so solid, this is the soil which will be taken out at the end from this soil sampler tube. On this soil we conduct laboratory tests. So the tube which is collecting this sample is called sampler tube, and this is in the shape of hollow cylinder. Okay, hollow cylinder. Now there is a design for the sampler tube. You can't just design taking some thickness, taking some edge. So that there are three things which we need to consider while designing the sampler tube. I will okay, let's go to the next slide. You will understand in the next slide how does it look, sampler tube, and what are the three things which we need to look at when we are going for the sampling. I already gave some introduction about the sampling, undisturbed samples, disturbed samples. Okay, see that there are two kinds of samples. One is disturbed sample, one is undisturbed sample. The sample in which the structure is also same as that of the structure when it was inside. When you are taking out, the structure of the sample is not changed inside. There is no disturbance in the structure also. The natural structure is also same. Because of that, it is called as undisturbed. If the structure is disturbed, stresses will not be same, because once you take out the sample, suppose you are taking sample from this depth, okay, some 10 meters depth. Exactly. If you apply the same stress which was there, same like that. Okay, same stresses if you apply all around when it was inside, then it is same. You can use that for shear strength properties. You find out shear strength properties on the undisturbed samples. Suppose the sample is disturbed, it is collapsed, now it has become powder. Now that can be used to find out the index properties. That means specific gravity and liquidity index, a plastic limit, all those things can be found out from the disturbed sample. Exactly. See, these are the sampling things and the sampler tube. Now let us enter into the sampler tube. So how does it look and what are the design properties which we need to look at? Okay, see, this is the sampler tube. This is the sampler tube. See, this is the sampling tube. The part, some part of the sampler cutting sampler tube. What do you say that? Sampler, exactly. It is a sampler tube. One part of the sampler tube is having sampling tube like this, and at the bottom it is having the cutting edge, because it will cut soil. So while cutting, it goes inside. Now if you see, this is the cutting edge, only this part. Okay, this part is cutting edge. Okay, and this part is sampling tube. If you see the inside diameter, this is D1, that is the inside diameter of the cutting edge, whereas this is also inside diameter, but that is inside diameter of the sampling tube. Now if you observe that D3 is more than D1, D3 is more than D1. Why? So when the sample is entering here, after going above this, what will happen? Sample will stand like this. It will not touch this sampling tube. If it touches, what happens? Because of the friction, the sample gets disturbed. That is the reason why we don't want this sample, this soil sample which is entering should not touch this sampling tube throughout. That is the reason why what do? We will give this inside diameter of the sampling tube D3 is more than the D1. That is how we design. Next, now what happens? See, this is the outer diameter of the cutting edge, that is D2. That is more than the outer diameter of the sampling tube, D4. Why? When the sample is when the sample is going inside, some sample is going this direction also, right? This should not fall on this much. If if it is, suppose if D4 is more, again it will travel like this and the total soil gets disturbed. That disturbance of the soil will affect this sampling. That is the reason why it will go inside, but the how much will it go inside, again that we will see. See, now coming to the inside diameter of the cutting edge, outside diameter of the cutting edge. That means if you see D2 minus D1 divided by 2, that means this one, this thickness, that should not be much more. If it is more, what happens, again the soil gets disturbed. This should be as small as possible, as thinner as possible. Okay, that is how it is designed. So finally, what are those three things which we consider while designing this sampler tube is area ratio, inside clearance and outside clearance. So inside clearance is, the formula for that is D2 square minus D1 square by D1 square. What is D2? D2 is the cutting edge, D1 is also cutting edge. Area ratio is only related to the cutting edge. Okay, whereas inside clearance, inside means we are talking only about inside. You have to consider only inside diameters, maybe sampling, maybe cutting edge, D1 and D3. That is the reason why it is involving only D3 and D1. D3 minus D1, because D3 is more sampling tube, so that's why D3 minus D1 with respect to the D1. So if you do this, that is called, this formula gives inside clearance. And what is outside clearance? Outside means only outer diameters. Sampling tube outer diameter is D4 and cutting edge outer diameter is D2. That's why D2 minus D4 divided by D4. Whichever is minimum, you should take that. Okay. Now these are the three formulas, three things: area ratio, inside clearance, outside clearance. These three things will define the cutting, the sampler tube design. So what are the ranges? This should be in between 1% and 3%. This should fall in this range, 1 to 3%. And outside clearance should always be, less than inside clearance. Inside clearance. This is the rule for the outside clearance. And area ratio should be less than 10% for soft clays. Okay. For other materials, it can be less than 20%. So these are the ranges. When you design these three things should be within these ranges. That is the concept behind this design of the sampling tube. Okay, now what is the question? So we know, now we can understand what is he saying. Inside diameter of the sampler tube. So inside diameter of the sampler tube means he has given D3 is 53 mm. And inside diameter of the cutting edge is kept such that inside clearance ratio. Inside clearance ratio is what? D3 minus D1 by D1 into 100. Whereas D3 is sampler tube ka diameter and D1 is cutting edge inside diameter. Both are inside diameters only, because this is inside clearance ratio we are talking about. This is given 50, but inside diameter of the cutting edge is not given. But he has given ICR 1%. That means this is 1%. So he is asking to find out inside diameter of the cutting edge. That means D1 is to be found out in mm. Okay. So let's find out that. Okay. Let's find out that. So we have been given D3 50 and we should find out D1 how much. 50 minus D1 by D1 into 100. This is the ICR. ICR is given as 1%. Okay. Now tell me what is D1. Can you tell me what is D1 value? Somebody? 49.99. Okay. Okay then. 49.99 mm. Okay. This is how we will solve. So in this way you can find out what is area ratio also. You can find out what is outside ratio, and you can see whether they are falling within the range. Right? So you do this as homework. Let us solve this thing in the next class. So with this I am completing the session. Is there any doubt? So if you put 1 by 100, that means what? It is not percentage. Then you should not use this 100 here. Suppose you are already multiplying 100, that means what? This is all percentage. So this is also percent. Then what is the value? $49.5 or 4.95? Yeah, 49.50 mm. D1 is right. Okay. Yeah, suppose you see if somebody is telling ICR is 1, just 1, okay, then what do? You don't multiply 100 here, you will just keep 1. Suppose you want to put 1 by 100 because it is in the percentage, you want to put 1 by 100 here, then you don't multiply here. It's simple. See, when you are multiplying, what is the percentage meaning? By 100. If you put by 100, you should not multiply here. This is itself is the percentage. See, this itself is the percentage. All are in percentages. This is the formula for percentage. If you put 1%, you no need to change anything anywhere. Okay. So with this, we are closing this session. Okay. Can I close? Yeah. So thank you very much. Any doubts? Next session I will be updating in the site, so you will be getting that. Last time I didn't update that, sorry for that, but this time I will update. Okay. Recordings will be available, that is available only through the authority which is conducting is, that organizing committee, they will be having the recordings, they will be sending the links for you. Don't worry, you will be getting this. May not be today, may not be next week, but you will be getting the recorded links, all the recorded links. Nothing to worry about it. Okay? Okay. Anything else? Okay, so I am leaving the call then. Yeah, thank you.